Hi everybody, this is Dr. Bricker here with a introduction to the Newton's second law Phet lab. So I'm on the our Brightspace page for the class, and I've clicked on the labs module, and here's lab 2. So it's due a week from today, the 27th. Actually, that's more than a week from today. So check this date. I'm not sure the day of the week. I think I gave you some extra time because next week is test week. So 10 days from today. So please watch the attached video, what you're doing now, and complete the lab assignment. So this is the lab if you click on it. And it's a Phet lab, which is Physics Educational Technology. So you'll do the lab, and I'll open up in just a minute. And then once you write your report, then you just submit it here. So just one file. Don't do it a whole bunch of pages, just one file like you did for the first one. So let me click on this and you can see what it looks like. You've actually experienced the Phet before. I showed you it in class. Okay, so we're going to be testing Newton's second law. So you've been told that this crate weighs 48 kilograms, that you'll see in a minute. Your job is to confirm that it's 48. You do not have a scale to measure the mass directly, so we'll use Newton's second law to actually measure the mass. Hint, it's not going to be 48. That's okay though. You're going to get what you get, and then describe, what's the percent difference, that sort of thing. So we're going to open up this Phet video, and we'll go through it. Before we do that, number 2, we're going to check acceleration. We're going to also click on forces, sum of forces, values, and acceleration. And to get this thing going, you have to have at least something around 130 newtons. So we're going to set the force at 130 newtons, see what the acceleration is, and then repeat it for 4 more different forces. Okay? And then you're going to have to use Excel or a similar program to graph force versus acceleration. And you don't have to use Excel. I mean, you might have it on your computer. It's on the computers on campus. Maybe you use Google Sheets, whatever you're comfortable with, or there's an Apple version too, I believe. Okay, so when you make the graph, make sure that you label the axes with units and names, and then also include the equation of the line. So this is what the data table looks like. Acceleration here, applied force here. So the acceleration is going to be on the horizontal axis. The force is on the vertical axis. Okay, more about that in just a minute. So your lab should have a cover page, so put your name on it, the name of the experiment, and then these different sections. Experimental design, so label it Section A, experimental design. State the goal of the experiment, describe verbally and with pictures, so you can do a screenshot of this whole thing. How you collected your data and how the data was used to accomplish your goal. Prediction, that's the next section. Draw a free body diagram of the crate, so put all the forces on the crate on there, and then use Newton's second law to predict what the mass will be in general, assuming that the frictional force is 94 newtons. So you'll actually have to go through, use Newton's second law, and come up with that. I'll talk about that in just a minute. Data, print out the data table, so you can use the table that I provided, make up your own, whatever you want to do, and also the graph of force versus acceleration. Again, make sure the graph looks nice, titles, units, things like that. Analysis, write down the equation for the line that you found from the graph. So you'll have the equation, and from that you could figure out what the mass and what the frictional force are. So make sure that you include that with this section. And then finally, E, evaluate results. Discuss your results, in particular state whether your experimental value of M that you got, and then this part here, taking into account the uncertainty of the slope, ignore that. Our data is pretty much perfect because it's a simulation, so ignore this part, taking into account uncertainty of the slope. We're not going to have any uncertainty of the slope. Agrees with 48, and it's not going to. They told you it was 48. It's really not going to be 48. You'll see that when you get your data, though. And also, was the frictional force you found graphically 94 newtons? And then be specific, use data to support your assertions. Okay, so let's actually see what this looks like. If you hover over here, control, click, or you could just copy that and paste it into your browser. Okay, for whatever reason it's not working when I do control click, so I'm just going to copy this and maybe go up here. Oh, it was just a little bit of a delay apparently. Okay, so there it is actually. Opening up, which it should. Control click always works. I'm not sure what the delay was there. And we'll get this Phet simulation. Okay, and then we want to pick acceleration. And we can put sum of forces, values, and acceleration on here. And we could start adding some force. I'm just using the slider here. And you want to get to the point where you have, well, let me start over here. You want to get to the point where you have 130 newtons. So let me just kind of let this play out for a minute. Okay, stop. Okay, now I want to apply 130 newtons. If I use the one on the right here, it just goes up by ones. If I use this one, it goes up by 50. I want to at least get to 130 to get this to start moving. Right now we've got too much static friction. But if I can get to 130, a little bit over a certain amount, 130, this is my applied force, 130 newtons. This is my acceleration. I can put those numbers in my graph. So 130 newtons is the applied force, acceleration is 0.72. So go back to the data table, and again you can use this data table if you want. Write down the acceleration, write down the applied force. Let me go back to the Phet. Now pick some other number. I'm just going to go up to whatever you want, 140 newtons. And then play. And there's my acceleration, 0.92. And then I will write that down. Now if you let this keep running in the background, it's going to end up going too fast and you run out of time. You'll have to start over. You'll run out of room actually. That's why I paused it. Let me go back up to maybe 160. I'm just getting some nice data points here. Play. And there's my acceleration. Okay, so do 5 different forces and accelerations. Make sure they're over 130 or so, or the whole thing won't even move. Okay, so that's just with the crate. Don't touch the friction setting over here. So then once you have your data, I'm just going to make some stuff up here. This is not real data. I'm just making it up. 1, 2, 3, 4, 5. I just kind of want, whoops, 5. I just want to give you a little refresher on Excel if you haven't seen it before. 100 and 150. Again, I'm just making up data. This is not real data. 200, just to show you how you actually can use Excel. 300. Okay, so I can take the data that I have here and put it into Excel. I believe it'll just let me copy and paste it. Let's see. Copy, and then I've got to open up Excel. Okay. Again, yours could be located somewhere different on your computer. Let's see if it'll let me paste the numbers. Okay, I'll just do that. So here's the numbers. You didn't have to copy and paste. You could just open up Excel and type these numbers in if you want to. But I want to use these to make my graph, so I will highlight both columns and all those rows, and then do Insert, and we're going to use a scattered plot. So I did Insert, and then Insert Line or Area Chart. Actually, I don't want to use that one. I want to use a scatter plot. Again, if you're not using Excel, you'll have to figure out what everything's called. But I just want a scatter plot. I want individual points. And I'm going to pick the top left one here. Okay. Wow, there's my my graph. Now, what I can do is quick layout at this point, because if you notice, there's no labels on the axes here. But if I do quick layout, I can pick some of these different templates. I'm just going to pick the upper left one. Okay. Excellent. And then you can go through and label the axis and put the units. Same thing here. By doing, you just click on it to do that, and then type in whatever you want. Same thing with this one. Click here, start typing. There's only one series of data, so I might as well just get rid of that. You know, it just says series 1. Well, there only is one series. So I can right click, delete. Okay, good. So make sure you put the axis title for both of them with the units. Make a chart title here. Now we want to put the equation of the line. So the way I do it is I just hover over one of the data points. And again, there's a lot of different ways of doing this. I'm hovering over this data point. I'm right clicking. And then I'm putting add trend line. There's the trend line. And then I want to put display equation on chart. So I've got to scroll down here. Display equation on chart. Got to click that, and then if you notice, here's the equation, and then you can grab it and move it wherever you want to. It's in slope-intercept form. So whatever comes in front of the x is the slope. So the slope here is 50, and the intercept is also 50. It turns out, right? The intercept is whatever. You know, y is equal to mx plus b. The b is 50. The m, which is the slope, not the mass, the slope, is also 50. So make sure you make a graph like this. You can move it around however you want to, make it bigger. You have to have this in your report, though. So you can copy it, paste it into your report however you want to do that. You'll need this equation. This equation will tell you the slope for the experiment and also the y-intercept. So what do the slope and y-intercept represent? Let's talk a little bit about that. Okay, so make sure you do the free body diagram. I don't want to give you too much information for that, but you know, look at all the forces, and then we'll use Newton's second law. So the net force is m times a, and then from your free body diagram, this is the part where you've got to supply the actual forces. I've got a force to the right, which I'm just going to call applied force. Minus whatever's to the left. This is the frictional force. Okay, so from the graph, we're going to be doing this. Remember, you put all the units and stuff. I'm just doing this quickly. Acceleration, force applied. You'll have some kind of line like this. You're going to have the equation of the line. Let me take what I have here for Newton's second law and add friction to both sides. So when I do that, F applied is equal to MA plus friction. Right? I've just taken the equation right above and solved for the applied force. Now this is in this slope-intercept form. Mx plus b. So when you take the applied force, vertical axis, acceleration, horizontal axis, you can sort of identify what the mass is without directly measuring the mass, right? So the role of slope is being played by mass. Luckily, it's the same actual variable. Now the intercept and the friction should be the same, right? So this is a way of not directly measuring them, but measuring the applied force and the acceleration and coming up with the mass and the frictional force. Okay, so what I'm trying to say is you can use this to figure out the frictional force and the acceleration graphically. Now there's a part where it says predict what your mass will be from Newton's second law. I mean, this is still Newton's second law here. What you can do is solve this for the mass. So use this equation, solve for the mass. Mass is F applied minus friction divided by A. The thing is, you don't know how much F applied is and how much the acceleration is. So you can't actually get a number for this at this point. You could for specific forces and specific accelerations. But this is good enough if you just have this general form here. Okay, that'll make more sense once you actually go through the lab. Okay, so have some fun with it. You know what sections to put on there. Any problems with Excel, just let me know. I mean, don't let Excel hold you up when you're doing the experiment. And then once you finish the report, put it all together, and then you can upload it back through Brightspace. All right, any questions, again, email me. Talk to you soon. Bye.